Hello, everyone. My name is Gauri. I'm your MC for this session with Jonathan Ouimet. Welcome to Managing AI Model Risk with Jonathan Ouimet and his team. So just before we begin, if you have any questions, please ask them in the chat with a queue in front so the facilitators can identify them. And lastly, if you have purchased a summit ticket and are joining us for the talks on November 17th and 18th, please look for an email from Hopin in your inbox today or early tomorrow. So a little bit about Jonathan. Jonathan is a sales and engineer at ModelOp. Jonathan works with Fortune 500 companies to understand their challenges with AI and decision-making model operations, ModelOps, and he demonstrates how ModelOp Center can help solve their ModelOp technical, operational, and business challenges. He has over 15 years of experience as a technologist and sales engineer. He has worked with AI technology products for the last 4 years and has many years of experience with digital business automation products. And so thank you. And without further ado, I will pass on the session to Jonathan. I'm going to mute and turn off my camera now.
Perfect. Thank you, Guri. So hi, guys. So my name is John. Like Guri was saying, my background is a bit varied. The reason we wanted to do this workshop at TMLS is because I'm based out of Montreal, and we are working with a few different Canadian customers. And I'd like to preface this by saying that I'm from ModelOp. I work for ModelOp. I understand that today's session is about de-risking models. So I very much want to speak as much as I can conceptually about the problems that ModelOps is trying to solve for. With respect to that, I'm going to bring some of my own knowledge and some of my own background to the table. Pardon me. My background is a bit varied. So I've done sysadmin work, I've done programming, I've done ETL, I've done big data warehouse work. I've been the guy with the pager at 2 o'clock in the morning taking care and debugging code. I've worked in consulting gigs. I was actually doing implementation of an automation software called Control M for a while. And Control M is an automation platform. So it's meant to automate a number of different tasks, which then drew me to where I am right now, because I also have a background. I worked with at Ouimet doing what's called RPA, which is robotic process automation. And then finally, again, automation here at ModelOp, doing ModelOps type automation. So a different type of automation applied to a very, very specific space. Let me go ahead and share my screen here, and let's see if this works. Janet, are you guys seeing that? It should be coming up.
We can see it.
Perfect. Thank you, Guri. Okay, so this is just the demo slide I have here, but what I wanted to hit on first and foremost is this, and the format of this workshop, guys, is that I'm going to speak through a number of different points. What makes ModelOps ModelOps? What's the difference between MLOps and ModelOps? How a ModelOps brings a very specific tool set to the table to help you de-risk your models, because risk for models is a huge thing, and there's a lot of different things we're going to talk about regarding that, such as OSFI and other cases where models have gone awry in the past and how it has damaged companies' reputations and things of that nature. So where does ModelOps come from? So the need for ModelOps stems from the enterprise needing full visibility into the life cycles of decisioning artifacts. Now, decisioning artifacts, that's the AI. That's the things that the modelers and the data scientists and the mathematicians are putting together to represent a solution to a business problem. So in order to track, you need something in place to track the life cycle of those decisioning artifacts, that code that you're writing, in a very model-centric way. And that's what ModelOps is bringing to the table, so that you can track performance, ROI, and that you can de-risk these models. You need to be able to remove as much of the risk from them as possible so that they run in accordance to their spec and they stay within necessary thresholds. And one of the things we do is that because the number of models that are hitting the market these days continues to increase, and because companies are more and more making use of artificial intelligence and really code to do the calculations on their behalf, what is happening is that we need to be able to accelerate in a safe way the deployment of this code into production. And to do that, much like CI/CD did for DevOps, we need a tool set that will help you govern and automate and inventory the models that you currently have at your disposal, no matter where it is you may work. So that's what ModelOps brings to the table. It's a comprehensive tool set of, and I'm, again, guys, I want to speak about this in a conceptual manner as much as possible. I understand that, coming from ModelOp, I don't want to be biased in this regard. I want to tell you guys that these are the concepts. This is our raison d'être for ModelOp is really that we want to solve these types of problems, and that's what our software does. But conceptually, you guys are going to get a cool tour of that later and to get a good idea of what that's all about. So that's what ModelOps has as a purpose. It's to solve this kind of problem. And I'd like to explain very succinctly that on the right here, so ModelOps is necessarily separate and distinct from data science, and ModelOps encompasses the model risk functions, including model validation, governance, and teams such as that. So ModelOps lies at the center of any organization's enterprise AI strategy. That's very true. So you need the ability to track all of these decisioning artifacts that are at the core of how you are taking care of solving critical business needs. You need to be able to tackle the business needs, but also be able to continuously deliver value with a pipeline tool that allows you to do that. So first, let's talk about MLOps. So MLOps is about the tool sets necessary to basically build the models themselves. So ModelOps, where we sit, so what ModelOp does, we don't do the building. We are just about the operationalization. But, and when I say that, you can also consider that conceptually, ModelOps is really about that. It's not about the building of the models themselves. So MLOps is about building the models. So think products like SageMaker, Domino, Data Robots, just writing, straight up Python and just figuring it out and getting the right input and output values and checking your inferences and checking your test data and making sure all that actually works end to end. Jupyter notebooks, that's another example, using any number of SQL sources and data sources that you would like. And then so MLOps is really concerned with the iterative development of models where they ultimately maybe end up in a runtime. So maybe they end up somewhere where they're currently serving, and maybe you've applied very specific monitoring to just that model to make sure that it's doing okay in that silo of development. So you've done this and you built it out in one specific place and it is doing the thing in that specific place. But this is an example of an MLOps architecture. So you are performing the work, and this is just to paint an overall picture. You are performing the work of creating the model that matches the business's requirement. So the business will come to you and say, hey, we need a new, a car model, a CAR models. And they'll say, we need it for this specific type of asset and to make sure that we are compliant, and we need you to be able to measure all of that. Well, then you get to work and you start developing it and you start gathering your data and your information about how that's to be put together. And this is an example of that kind of flow whereby you are going to code it out. So the modelers or the data scientists or whatever role and whatever nomenclature you'd like to use, the folks that are actually building the code and making sure that it tests correctly and that it runs correctly and it's sampled correctly, all that kind of good stuff is all part and parcel with what MLOps brings to the table. So a comprehensive tool set, a workbench that allows you to build out these types of things and gives you all those good facilities and all the good tool sets that allow you to actually put all that together. But let me see about There we go. Okay, so operationalization, and what you're looking at here on the right is they're extracts of our BPM engine. So these are actually just snapshots of some of the automations that we actually have that we serve in our software. But the point is, the reason they're here is to explain that you need a rules engine that overlays the MLOps stuff we were just talking about the actual workbenching, the actual putting together the actual models to make sure that they conform to the business rules that you've set out. That's one part of it. But you need a store of information that overlays not only the creation of the model, because that's part of the story. You need software that will create a overall life cycle of every model that you have in your enterprise. And the reason why that's important is because you need the ability to track. You need the ability to audit. You need to know where all of your models are, just like we do with regular software development. But models are a bit of a different breed in that they have a number of different aspects to them that are unique to them. So things like schemas, things like assets, things like what platforms they're allowed to run on. I mean, that's a coding thing as well, but things like assets and things like documentation and very specific types of things like that, including metadata surrounding them. The automations that you're looking at here are responsible for doing all the checks and balances, making sure that all those things are actually in place and are actually taken care of and have been respected as part of the actual business process of whatever enterprise we're talking about. So like you see here on the left here, this includes models based on machine learning, knowledge graphs, rules, any kind of models that you can throw at it here. You need a way for including everything into the automations that you're deploying. You need a way to include the ability to check, to do all the checks and balances on all the models that you've put together, no matter what purpose they might be for. So, which is why ModelOps as a solution is where we go with that. So on the right, we can, that's a separate discussion. That's really our architecture. That's how we do our thing. So we don't have to talk about that. You guys are more than welcome to ask me questions. I think if you ask questions, it pops up in the chat at the top, and that's great. But what you're looking at on the right is actually our own architecture. On the left over here, we have facets of what you would want to get out of a ModelOps solution. And speaking from experience, the customers that we work with, we normally, let me break it down for you like this and tell a bit of a story. Sometimes we'll approach a customer or a prospective customer and we'll say, tell us about your model validation process. And then normally they'll bring us into a long discussion with a bunch of PowerPoints, PDFs, all kinds of information about how they use a combination of 4 or 5 different technologies all jammed together. Like you've got email, SharePoint, sometimes they use CRM tools, or not only CRM tools, but document management tools, central data stores, SQL, so they just use flat out databases or off-the-shelf products, all kind of put together to allow them to actually approximate the business process they have at hand in their organization so that they can actually operationalize the putting into production of their models in a compliant fashion. So on the left, this is a set of things that you should want to get out of a ModelOps solution. So when you're operationalizing, you want to make sure that you can, for instance, leverage your existing IT infrastructure. Absolutely. So you need to. That story I was just telling you about when we speak with prospective customers or with our existing customer base, they all have varied infrastructure. You need to be able to play within those bounds and to accept what is there and to enhance it, just as a good thing to have for ModelOps, because we know that every environment doesn't only have one MLOps workbench building tool. They might have a variety. They might have 4. And those are all siloed around. How do you overarch all of that? How do you bring all that under one roof while still accepting the existing infrastructure and be able to install right next to it? I mean, that's a huge thing. So that's a big and very important thing, especially from what you're looking at over here on the right. we're containerized. So like the way we solve for that is that we go into containers. There's also other products out there, like for instance, Jupyter Notebooks, just as a workbench, as a ability to craft out your actual models themselves. You can bring that anywhere you want it to go. So that's also containerized, and we make it part of like what we have when we deliver our software. Why do we do that? Because you have to be able to accept what is there. So integrating with your existing investments is very important. Becoming the conductor of the orchestra, as you see on the left, the second to the bottom point here. That's very important. So the automations we were looking at before, and we'll look at them. We're actually going to go through one live together. And as workshops go, it's a bit weird over Zoom. Normally I do these in person, but COVID. That's the world we live in right now. Point is that when you codify and when you automate the business processes that can tie together all those strange disparate systems that have all been jammed together to achieve the goal of governance, really, you achieve a faster return on investment. You achieve the ability to go to production more quickly, and to do that by having a machine do all the checking for you. You can gain some serious time and some serious effort lost. If you think of tools like Jenkins, for instance, CI/CD tool set that allows you to do a number of checks and balances and automated builds and automated deployments, things of that nature, ModelOp and ModelOps has as a goal to solve for that as well, but in the model context throughout all those different workbenches, with all the things that we know models take, with all the versioning, all the restrictions that need to be in place, limiting what data scientists are allowed to do, the separation, and we haven't even gotten to the notion of the separation of first line and second line, which are, and third line, but third line is something else. The separation of the model development and then the model validators, and that they need to be able to be run in separate environments. And really, if you are developing a model, it has to be done with comprehensive documentation. The documentation that you're creating needs to be so usable and so well written because of the implications of the decisions that the code is making, that if you were to give the documentation to someone outside of the organization, it would have to be readable and they could replicate what it's describing. Stuff of that nature. That's the kind of important those are the important aspects of models that need to be taken care of by those automations, so that you can, and it can be tedious, and that's what I'm kind of getting at here. It can be tedious, and so you need to put that kind of stuff in place so that you can actually get from business concept all the way out into a production environment and start serving the business on what they paid for. They paid you to develop. What are you going to make for me? I kind of think it's coming out of someone's budget. It has to be. We don't have to focus on this too much, but these are the questions that we look to answer with our software, and these are still conceptually the questions that any ModelOps software would need to answer for. So I need to know where my models are. I need to know how long they've been running. Do some of them need to be decommissioned? Are some of them showing signs of drift? Are some not performing? Am I compliant with all regulations? Things of that nature. So this is just a subset of questions that are answered by a tool such as that is a ModelOps tool, conceptually again. And this is that life cycle I was describing before. So this is very much in line, and this is kind of so this was one of the folks that work over on our team. So our VP of product, he has a background in very specifically in this, which is the life cycling of models, and he painted a picture for us here, and this is great information in terms of what a life cycle should look like from a ModelOps perspective, and why ModelOps needs to be put into place to de-risk your models, and at which points in the life cycle of a model, from an overarching standpoint, do you need to be able to de-risk. So the use case definition at the beginning, you need to start as soon as there's an idea, as soon as the business has something that they want to put together, you need to start somewhere. So they're going to come to They're going to come to the model development team. They're going to say, listen, we want to solve for this very specific financial reporting, like maybe some IFRS stuff that's been plaguing a lot of the customers that we work with recently, because it's pretty loaded. What do you do first? You have to create a definition. So you need to define the model. You need to define what is going to be necessary, and also its risk classification, very important. So you need to be able to associate a risk to that model and say that this is either high, medium, low, or whatever kind of other risk classification IDs you might use internally. There are a number of ways that our customers do that. Pardon me. But the point is that you need to be able to associate a model to a level of risk, and that's very important. Development then happens, right? So the model developers will take that information and then they will start putting something together. And during this time, the ModelOps solution may very well just be sitting there waiting for that model to be created. And that's okay. I mean, that's what it's supposed to be doing. And once the modelers or the data scientists are happy with the model that they put together, they'll propose candidates for productionalization, which then need to be validated. So then you have your model validators. Now, this is where the rubber hits the road for a ModelOps solution, I would say most strongly, which is we give you the ability to, or ModelOps as a capability gives you the ability to automate all of the aspects of a validation process in disparate siloed systems and siloed environments, like I was mentioning earlier, because we see a variety of things. The ability to automate all of the key points and all the triggers and all the gates and all of the checks and balances and all those types of things that need to happen before they can even get into production. Productionalization can also be automated. So to send out a model so that it gets actually loaded up and put into the right runtime so we can actually start serving as per specification. Monitoring can be applied within ModelOps, so that's another key capability, the three being really, so if you're looking for a ModelOps solution, you're going to want to look for inventory, which is critical to validators as well as to governance teams. You're going to want to look for automation, because you need to be able to automate, and that's one of the reasons I joined them. Coming from an automation background, I saw this kind of stuff and I said, this is fantastic. You're doing automation of a very, very specific type of case, very specific type of code, very specific type of business asset, really. And then you have monitoring. So the ability to track and to make sure that your models are actually doing okay, but also in a central store. So you're bringing all that information into a central location. You can see everything from one place where the documentation is stored, the metadata is stored, and then you also have an indication that there might be a model that has undergone some kind of drift, some kind of performance degradation, and you want to do something about that. And there's a number of things you can do, and you can automate. You can do things like automatic remediation, or you can allow for the solution to just message someone and say, hey, we've got a problem over here. You got to come check this out. And finally, retirement. So retirement's pretty typical in terms of what happens when the model is done operating, and that totally depends on the type of model that you're building out. So you might have some CCAR models that are in place that you run 3-4 times a year, and they're probably not going to be subject to tremendous drift. They're probably pretty stable. Stability analysis is a very important aspect of model development. You want to make sure that your data is not all over the place. You want to make sure that you have relatively steady state so that you can continue to use that model, and then it might actually last longer. Some are more volatile. Some, some scikit-learn, or maybe some deep neural or some convolutional neural net stuff that you might be putting together. Stuff that is more volatile might need to be retired sooner and might only be given an authority to operate for a reduced period of time. So any ModelOps solution that is meant to be used to have your models abide by this kind of life cycle. This is the way we see things. This is also the way the customers that we work with, the prospects that we work with, this is the way they see things as well. This is a very typical type of situation. And what I'll do is I'll show you guys one more slide, and then what we'll do is we'll go into a demo. I'd like to ask for questions between this and the demo, and then we'll It'll be kind of like a demo, kind of interactive. I see Sling in the chat here. That's Janet. So I work with Janet over here at ModelOp. If you guys have any questions, you can just post them to the chat, and we can have a discussion. You can even ask them out loud. I'm not averse to answering it and having a good discussion. That's kind of what this workshop is meant to be about. So the last thing I want to show you is this, and we're going to then dive into it. So what you see in the middle, that circle, those are the typical things that make up a model. And things like, and you can see some of the keywords, and I chose some of these keywords because they come up again and again and again. Classification models, random forest, using Python, using R, Equitas to measure things like bias, TensorFlow as a software framework for building up these kinds of models and doing like ML. But the things that surround it are what a ModelOps solution should do for you. So make sure you have information about what platform the model is meant to be targeted at, the versioning of a model, very important, the schemas that it should expect on the inbound and on the outbound, because you need data quality as part of how your models are being asked to create inferences for, or to score. So you need that type of checking. And it depends. You might have a model deployed to a runtime somewhere, to an actual endpoint, and you want to just leave that there, and that's okay. But if you did want to do that kind of checking, that's something that a ModelOps solution should also allow you to do. To monitor, of course, storing of assets, your source code itself, the metadata, super important, and the documentation. Honestly, documentation metadata are crucial to the validation team's efforts to making sure that everything that is created that surrounds the model is as complete as possible. You need all of that. If you don't have that, there's a very, very high chance that your model will be either disqualified or you'll just be told, hey, sorry, your stuff isn't making its way into production because you're missing a number of things. And again, if you can automate as much as that as possible to inform the developer quickly, or to inform the modeler or the data scientist quickly that, hey, your stuff is not going to be able to get there fast enough, maybe send out a notification and with an explainer. So one of the things, there's a few things I want to hit on here. I'm going to move this aside. We don't need to do any more real slideware, but I wanted to talk a little bit about risk. And this is just a Reuters story here. And this is something that happened a few years back. It was, let's see if I can make this a bit bigger. Right. Okay. So I want the case on the right I have here is about bias. And this is to answer something that I want to first talk about that's actually on the left. So I know this is the TMLS, this is the Toronto Machine Learning Summit. So I want to start this off with a bit of a Canadian spin. So on the left is OSFI. So OSFI is our branch, our superintendent of the financial institutions, flat out. So in the United States, they have a different system, a different set of regulations called SR 11-7. So we have something called E23, which some of you are probably familiar with. It's an interesting set of guidelines that help you apply rules for dealing with risk. And this is very specific, deposit taking institutions, okay? And the reason I want to hit on that is because banking and really what we call the BFSI space, banking, finance, securities, and insurance are the main industries that are hit with regulations or have always been hit with regulations sooner than other industries. And I'm just speaking about that in a model-centric context. And the reason why that's important to mention is because banks being hit hard with regulatory compliance type fines, or banks getting hit hard with regulations that are intended to control how they operate their business, is what spurred on the need for this type of software, so the ModelOps type of software, by and large, and I'm just saying this in generally from what we've seen in the customers and the customer base that we work with, because of all the existing regulations and because of the fact that they need to adhere to some very strict regulation, and they need to also perform and actually get models into production. So you need to apply complex regulation, and you need to be able to make sure they're compliant, and you actually need to get them into production as fast as you can. So those are two conflicting interests: making sure that the regulations are taken care of and that all the boxes are checked and all that, and then also the needing to deliver and needing to grow top line revenue or reduce costs or whatever it is that the model is sets out to do for the organization. So on the left is our so in Canada, our guidelines for dealing with model risk and the things that are necessary to take care of your models from a day to day. There's a similar type of list like this in the United States, which we deal with relatively frequently as well. But some of the fun things you can see here is, like, for instance, model inventory. Some of the things that you need to have as part of a model inventory: model name and description, materiality, model owner and developer, references the type of source data used for the model. All this kind of good stuff can be made part of the metadata of a model. So that's something I hit on during that the PowerPoint that we were just looking at before. You've got a large amount of information that needs to be made part of the registry of these models, the inventory itself, so that you can cross-reference it and make sure that everything is in good standing order. All this to say that just because banking gets hit, and banking and financial institutions and securities and insurance get hit pretty hard with this type of regulation, doesn't mean that other private industry doesn't. So what I'm saying is that if you look on the right, we have a story whereby Amazon, so they had a recruiting AI bot that was actually sent out to vet candidates, to vet their resumes, and to automatically pop to the top the top candidates for given roles. And what ended up happening is that because the validation for these types of models wasn't done correctly, and not enough digging was done into how the math underlying all of it was actually coming to the conclusions that it was supposed to be coming to by the validators themselves. What ended up happening is that the model ended up drifting into a space whereby, because the historical data showed that more men got hired than women in Amazon at Amazon over time, it ended up becoming biased against women. So that's a data sampling and inherent bias in your model. So all this to say is that just because banking has been one of the roots for the reasons of the creation of a tool set such as ModelOps doesn't mean that other industries aren't impacted as well, and doesn't mean that they can't learn a lesson from the banking industry itself, or the banking finance, all that, right? So my point is that there are places of applicability for this type of software pretty well anywhere there is an AI presence, anywhere you want to increase efficiencies, anywhere you want to increase the automation of the deployment of these complex assets that use complex mathematical models to solve complex problems. You can have this be deployed in any of these different types of organizations to achieve exactly that. Keep their head above water, keep everything in the green, make sure everything is performing adequately and correctly, while allowing you to maximize your throughput and get things into production. So what I'll do here is I'll pause for a minute or two. I'd like to just ask, because this is just kind of to preface what I'm going to show you after this, as a few of the mechanisms that we have in our software, and how, and hopefully, again, conceptually, that they elucidate some thought, and they get you guys to think about what could be important for your own organizations, or some problems that you might have faced in the past. And again, this is meant to be dynamic. So let's see the chat here. Eve, how to deal with such bias risks when model training cannot enforce fairness because regulation does not allow it to knowing when a sample is from a protected group or not? Oof, that's a good question. Okay, so read this a couple more times. Not allowed to knowing when a sample is from a protected group or not. So, see, that's tough. That is tough. So for us, we do have the ability, and okay, I can preface this. Let's see here. I can preface this by showing you something real quick. So on the left here, so this is our software, but I want to talk a little bit about, let me see here, this guy will do just fine. And in the schemas, okay. So one thing you'll notice here is that the bias inherent in the data coming through, you need to be able to classify the inbound information and to ensure that it is either treated accordingly or it is maybe held aside or sent to a separate model or what have you. You choose which way you want to go there. But one thing that we made sure to make part of how you perform inbound, so schema checking on the inbound, one of the options is protected class. Okay. So is Eve on the line with us right now?
Yes, I am.
Oh, you are. So can you tell us a little bit more about where this is coming from and maybe your space?
I remember that when this news came out, there was quite a bit of discussion on the subject, and I recall that one of the limitations about, say, trying to train a model and enforce it to be fair, at least at training time, was not feasible because one could not actually build a training data set and look at, say, in this case, in gender. So if I'm training a model and I try to enforce fairness, I'm going to make sure that I actually do look at gender to make sure that my training model, like my model, is trained to be fair by construction. But that was not an option because regulation or like legal would never allow us to build a model and say that we actually took into account gender information, for example.
Mm.
So it's less of a technical issue, at least from that point. And one would not be allowed to build to enforce fairness in building the model because regulation would not allow them to look at the gender information.
It's interesting.
I don't want to derail the discussion. Oh. Like if it's too tough, it is difficult. But
yeah, no, this is a very interesting. This is a very interesting question, and it's interesting because it's very much at its core, it's a regulatory type question. So, yeah. So I saw Matt's little question here. Can it be solved without the data?
Yeah, I recall that some discussions around the time were even like, okay, say you don't build you build the model, but don't try to enforce fairness. At the best, you might be able to have like a validation or maybe like a test set that maybe you're allowed to look at this information, so you can make sure that a model is fair or not. But you're not gonna be like you're hoping that at some point you're gonna hit a model that's fair and it's gonna pass the validation test or the metrics on the test set, but you're not allowed to train the model to be fair by construction because
yes,
you cannot look at the protected class, be it gender or some other at training time.
Yeah, it's very much so this is very much a question about how after you've done your training, after you've built out your model and say you've operationalized it, how do you stop it from how do you stop it from actually reading on the protected classes themselves and making an inference based on the protected class? How do you, in a sense, after you've done your training, you filter it out, but even if you filter it on the back end, geez, that's a good question. You know what I would love to do? So Eve, do you mind if I take your question? At ModelOp, we have a few data scientists that work with us. I would love to ask them the question. And do you mind if I get back to you with some of their thoughts? Is that okay?
That sounds wonderful. Yeah, that's okay. I don't want to derail the conversation. It's just because when got to that, and I remember the discussions at the time, I thought maybe something had evolved since.
Yeah, I you know what? Let me So since it evolves, let me ask them the question, and let me here. I have to take a little. I'll take a little screenshot here because I think Zoom doesn't let me. I'll set that aside. Zoom doesn't let me do a copy paste. But what I'll do is I'll take that aside, and I will ask the question, and I'll get back to you if that's okay. I think we can get in contact with you guys through the workshop, and we can
Sounds
get
good.
your information.
No
Is that
problem.
cool?
Yeah,
All right,
no,
great.
that's cool. Thank you.
Cool. So, and also Matt said here, can it be solved without the data? Again, Matt, if you're cool with us reaching back out to you, I can provide the thoughts of our resident data scientists and send that back your way if that's okay. And I see Adarsh here has a question here. So the takeaway from the Amazon case is to balance out the data set for class samples to be even. Just talking data-wise, but shouldn't the model be ideally trained on data that resembles the real-world case? What is your opinion on this? So that's a good point. They in the article itself, it's interesting. What they did is they did their best to, like you can see it shared on my screen here. They tried to remove bias by removing certain keywords. So it penalizes resumes that have these words, and it downgraded the graduates of 2 Albans colleges according to like that. So they edited the programs to make them neutral to these particular terms, but that was no guarantee. So yes, Adarsh, to your point, the data set of who got hired at Amazon, the historical, you can't change that. That's a problem, and I guess what you could try and do is do like a strange down selection of taking your most highly performant candidates on both sides, men and women, and maybe build out a data set that way. But that again would prospectively be inherently biased and would have interesting and maybe tilted results. But it would have to depend on actually seeing what information they actually had and the types of features that they had selected during that.
That's the tricky thing, right? Like you still need to look at the gender information. Oh, sorry, I just jumped in.
No, go. That's fine. That's cool. I want this to be a discussion. You're absolutely right. But Eve, that was Eve talking, right?
Yes. Sorry.
What are your thoughts on this Amazon article?
I mean, my thoughts are largely that it focuses a lot on on the PR side of it, right?
It does, yeah.
But like, how would one go about actually doing this right when if you're trying to solve the problem yourself, how would you go about building such a fair data set or building the model when you're not allowed to look at the gender at all? Mm-hmm. Because like if you build a data set and train, the data set was built by looking at gender and someone a complete another take, like another headline would be something along the lines of this company is recruiting models, but building their models looking at gender information or something like that. I don't know. Like I feel that it can be sensationalized either way, and even if one is allowed to look that information at all for legal reasons.
Yeah, and so there's some really great thoughts. You guys are asking some great questions here. So Gonzalo and Shervin, they built up on this, and also I see, is it Epson H, or is it just Epson? All this kind of goes together. This is fantastic. So making a synthetic data set, yeah, you can. So you can fabricate, like I was mentioning, you can downsample, you can try and build out what is like the ideal world, and you can do that kind of thing and build out a training set that is closer to what you want to try and abide by, to have like minimal bias. Like if Amazon is aiming to have a perfectly symmetric, representational employee population that is representational of the population at large. I mean, they could try and do that, but it'll prospectively skew the model into a different direction. All that testing, all the candidates for release that they end up coming up with are going to have to all be pitted against one another to figure out what actually works best. How will the use of synthetic or oversampled data affect the risk of a model? Yeah, exactly. So If you're using a downsampled or like a synthetic data set that you've decided to craft out, that like this is the ideal, this is where we want to go. Does that mean that and okay, so let's say you craft out, and I really like this question because it's a good brainstorming, possibility here. Maybe you downsample and maybe you create a synthetic data set that is comprised of the ideal situation. And you start working with that and you're just like, this is where we want to go. We want to see this mix of men and women as candidates. That would be, can you please give the link to explore this information? Sure. There you go. Sorry, guys, I'm just answering this thing. It's just this Reuters article right here. Oh, you're more than welcome. So you set out to create and to solve the problem to get to the ideal situation, and you end up building out a model that ends up skewing you, although it being unbiased and fair, doesn't get you. And see, that's when it becomes a business decision too. What if even in the mix of the men and the women that are hired, you end up not getting the candidates that were of the caliber that you were expecting? So does the model no longer then do what it was actually set out to do? So the problem statement is now no longer valid. You're now doing something totally different. And so I see Epson H, he said here, if it can't be debiased, it shouldn't be productionalized. And I think that's true, because you're now no longer solving for the same thing you set out to solve in the first place, which is good in a sense. The checks and balances, the gates and the validations that need to go into making sure that a model adheres to the documentation, the test results, and the things of that nature that it was set out to actually solve for need to match with what a data scientist or a model creator is actually setting out to deploy into production. So if they choose to try and deploy something that really does not perform according to spec and doesn't have the correct performance thresholds set to be able to actually perform correctly and be performant according to what the developer indicated that it would be doing, then there's a massive problem. And yes, you're absolutely right. It should not be productionalized because it's not actually correct. It's not what the business paid to get developed, flat out. So really good questions, guys. I like all this kind of stuff. This is good. What I'd like to do is for the questions I can't answer, I'm going to take those back and talk to some of our data scientists. And if you guys are amenable to it, I'll reach back out to you and we can keep the discussion going. Before I continue, let me see here. So Matt says, in parity requirement, maybe using two models would be some way to go. Yeah. Predefined quota equal with the population distribution, the cultural integrity between the candidates chosen by models might be the problem. Yeah, that could be a problem. I mean, sorry, that could be, yeah, well, at least one of the problems, yeah, for sure. So, yeah, absolutely. And the problem with quotas is that's that caliber problem I was saying. Like if you're just trying to fill seats, does it mean you're getting the people with the acumen, the job history, the accomplishments that you're looking to hire for? And it's a tough situation. And that's all really just surrounding just this Amazon article, but there's other cases like this that can traverse these types of problems, right? So, able to choose from then, and the bias comes from STEM educative problems. Yeah, that's definitely part of it. That's true. Yeah, that's definitely a huge part of it. Andres, I'm answering your question there. Makes a lot of sense. So I hope you guys don't mind. What I'll do is I will bring you through a little kind of walkthrough of some of the ways that our ModelOps software works, and I want to speak to the concepts of all those things. I'm trying to, as hard as I can, to not be here to sell to you guys, but to show you. And this is meant to be an education session. I want us to talk about things and to because it's a workshop, really. And I'll show you the way in which our software actually works, and the reasons we do certain things, and the reasons that we we propose automations in a very specific structure, and we'll walk through it slowly. And again, I'll monitor the chat window at the top. If you guys have questions, please feel free to ask. So what I'll do here is I'll go to, and I'll sign back in. Yes, please. All right, cool. So this is just the dashboard of our software. What I'll do is I'll give you a quick high-level overview of what you have here in front of you. So the three key components of what you should expect of a ModelOps solution are inventory automation and monitoring. Those three things put together make up for all of the key components that you would need to achieve governance. And what's interesting is that in the teams that we talk about in organizations that deal with modeling and with data science and all the mathematics backing it, is that you have your model developers, you have your validators, and then you also have the governance or the model risk team that have people in both of those teams. So they are involved with making sure that the developers and the way that they are putting together their code and the way that they're testing and the way that they are choosing their selection, like their population selection, their samples, their historical data, what have you, for whatever kind of model they're trying to build out, if it's a linear regression model, if it's a time-based series model, whatever that might be. They're working to do those types of things, and you do have some risk people that will interface with them directly to make sure that they're doing they're doing that in a as little or as least or as most risk-free way possible. And then you also have risk folks that are involved in the validation team, and it is interesting because there's a massive overlay of talent between the developers and the validators, because the validators need to be able to crack open the code and say, hey, what are you actually trying to calculate here? What is ModelOp? Oh, here, sorry guys, I just see a quick question here. I'll resume my thought on the validation team and the developers. So ModelOp is, so we are a company that makes a ModelOps solution, and we're actually gonna see it in operation here. And the reason why we wanted to attend the Toronto Machine Learning Summit is because, well, not only because I kind of push for it because I'm Canadian, haha, but I wanted to push for it because it's a very interesting space, and it's a type of software that solves for a very specific problem that is becoming more and more prevalent and more important and more visible. So it's meant to serve as an educational session. We are a company that sells a ModelOps solution, which is ModelOp Center, which is what you're looking at on the left. But what I did want to actually do is just speak conceptually about all the features that we bring to the table. Does that make sense? All right, cool. So the validation teams and the developer teams, they have an overlay of talent and knowledge, and they need to be divided by a firewall, which is pretty crazy. So you've got folks that are putting together models that want to get them into production, and then you have folks that are playing the police, right? You're not allowed to bring this into production because this particular this particular logarithmic or regression analysis that you're performing here is not outputting or is not using the right kind of data or the right coefficients. This is wrong. You should have been approaching it from this other angle. It's so funny because in development you have the notion of peer review. You have the notion of for all those of you who remember like XP programming and or having a buddy programming, someone sitting next to you and being like the devil's advocate to tell you that won't work because of such and such. I mean, the same notion happens here. What's nice about a ModelOps solution is that it brings all the tools to the table to allow you to automate as much of that interaction as possible. And that's what it's meant to do. That's what ModelOp Center does as a focus. So have a look at this, and we'll talk about some of the different screens you're seeing here. And we're going to go through a simple automation here. So we're actually going to go through this guy. And we're going to have a look at what it looks like to actually go through an automation of bringing in a new model, proposing it for production, attaching documentation, things like that, so that if I was a developer trying to get a model into prod, I'd have to go through all these gates to be able to get there. So on the left, We have just a dashboard landing page with information about what is going on in the system from a high level. A model inventory along with monitors as well. So this is where you would store all that kind of information. One thing that's important, like I was mentioning earlier, every organization we work with has a different mix of workbenching tools, different mix of languages they like to use, different mix of plugins and third-party systems and things of that nature. And because of that, we need to be as accepting as possible. So we allow for the import of any kind of model. So you'll notice here, you got Python, you got some C stuff here, some old PFA, R. You've got some SageMaker up here. Is this from AWS? There's a Python 3 one here. So point is that you should, in any kind of ModelOps tool set, have the ability to view all models across the enterprise, because that is just what you need to do. You need to have full visibility into all of that. You need to be able to automate. So the automation portion, so that was inventory. This is the automation portion of what I was talking about. So you need to be able to define automations that, and this is very, very important, that lock the developers down in a very specific way. So you need to be able, and this is part of the de-risking. How do you de-risk? You need to force developers, pardon me, guys. You need to be able to force developers that if they want to propose a candidate or a model for production, it has to go through the same acceptance process to make its way through validation as everything else that's classified in that particular way. So if you have a low risk model because the model reviewer or the validator decide to look at it and say, okay, this is a low level, this is not very important. This is for an internal report that's generated twice a year, and it's just a very simple, a regression model that does, or linear regression model that doesn't do anything very fancy, relatively low risk, coefficients look okay. Let it go through a specific tier of productionalization. So tier 1, we put more scrutiny on it, maybe because it's a high risk model. So you can see the complexity of the automation here is a bit higher than something like this. So tier 2 is maybe a little bit more lenient because it allows a lower, risk category model to go through, and that's cool. You can build this way, and it's meant to be built this way, but you do have to force the model developers to go through this process when they propose something for production. It's very, very critical that happen. They need to be locked into a specific path, and if they're not, then there's an issue there. You can't let them just say, okay, well, I'd like to push a high risk model through the low risk flow. You can't do that. Whenever, and there are ways of doing that. You have to lock it down. So security is a big concern there. But when you version a model, when you propose a candidate for production, it needs to be tagged in a certain way. There needs to be a metadata associated to it that then forces it down a specific path, things of that nature. That's all important. That is something that you should be expecting from a model ops solution. So again, this is a higher level view. And like I was saying earlier, you've got MLOps, which is really the workbenching, and then you have the higher level view of this type of software, two very different things. This is about making sure that the business is aware that everything that they are pushing through that is a decisioning artifact is actually compliant to the business process to de-risk everything that is being pushed by the modelers and the data scientists, and that it conforms to the validator spec to make sure it gets all the way through so that you never get hit by the third line, i.e. external auditors, to, oh yeah, here, sorry, Irina. Yeah, definitely I'm gonna zoom in for sure. How about this? I can keep this up here. Let me just move the chat over here. And this will give you an example of what you're seeing. Irina, is that okay? Okay, perfect. So this is obviously just a subset of the totality of what we're going to be looking at, but the point is that you need to be able to enforce, like I was saying, the validator's perspective on pushing a model into production, and that's how you de-risk a model. So you need to enforce everything you're looking at here is an individual step. So things like model completeness, creating model documentation, validation, so validating the compliance with things like Veracode. So if a developer, if a modeler, if a data scientist decides to create a model using a framework that has been deprecated and is no longer considered as being secure or has flaws or what have you, then systems like Veracode are set out to say, okay, well, version, I don't know, 2, and I'm just making things up now, but version 2.1.4 of Pandas is no good. There was a CVE that came out, there's a vulnerability, and you're not allowed to use that framework. Well, you need to stop the deployment dead in the tracks right there because the developer tried to do something that they shouldn't have been doing. Completeness checks, so making sure that all of the assets associated to a specific model are actually in place and available. Again, very important part of the overall life cycle of making sure that everything is in place before it even goes to production. Determining your risk. So this is something that would be applied when we were looking at that I like to call it the Chevron slide, when we were looking at that over here. So this part of the automation on the left is associated to this part right here, the define part on the right. So making sure that everything is properly classified. Is this a specific type of model that is going to need to go down a specific path, yes or no? You need to determine that. So you need to do that again to de-risk the deployment process itself. You need to be able to perform your smoke testing. So you need to be able to look at a model and run it through a test using the spec'd out information and the sample data sets or the test data or what have you, whatever's been provided as part of the dry run, to confirm that performance is what the documentation says it is. So you need the ability to automate those types of tests to ensure that the validation is correct, and also to wait for an overall review before even allowing a model to then make its way into any kind of production or any kind of deployment. In this particular case, this automation actually, it does all those things that I was mentioning. So it does, the risk classification, the uploading of the assets, the making sure that the how do I say this, the creation of the model documentation, and also the model documentation from the use case document actually happens. Snapshotting. So snapshotting is versioning of the model. So we're going to actually watch this automation play out live while we do something, which is to trigger an actual automation. So let me just make this a little bit smaller for a second here. On the left, as part of, again, of a ModelOps solution, and it doesn't mean the model has to live inside of the ModelOps solution. The model can be external to a proper ModelOps solution. It could be sitting anywhere as long as you are able to read some of the data associated to it, to be able to monitor it and make sure that, again, the documentation, what it's spec'd out to do, what should be expected in terms of performance, the thresholds that have been set, that everything is actually in conformance to what the model was expecting. So you have the ability to tie in engines where, from a ModelOp perspective, from our software's perspective, the ability to run those tests, to run that monitoring in a location, and then to maybe take action depending on that. So you can actually fire off automations if there's a threshold that gets burst past because you run maybe daily, weekly, monthly monitoring jobs on specific models. So all just good stuff, automatic triggers, automatic monitoring, things of that nature. And then batch jobbing. So this is just an indication of which jobs ran and what's what. Let's see here. So Andres is asking a question here. So nice comment. Happens a lot when using TensorFlow when moving stuff from 1.0 to 2.0, or simply deploying a Docker requirements.txt. Yeah, Andres, what's that in relation to? You can come on the microphone if you'd like as well, if you'd like to talk, or you can just type it out. It's up to you.
No, it's that I like this ModelOp because it happens a lot when you're trying to move stuff and you're using old code and moving stuff to the new code, and boom, everything explodes, and the model was working fine, but then somebody decide to do an upgrade of the software, and it's not working anymore, and you're like going like crazy around the wheel trying to see what's going on, and then you realize how a complete you can.
Yeah, it's a bit hard to hear you, Yves.
One moment.
So Yves, you're confirming what Andres has seen in his environment. Is that correct? Oh, I'm sorry. It's just because sorry, on my side it was just lit up that way. Okay, perfect.
Can you hear me? Or?
You're very low. Maybe it's just the microphone gain. But I think I caught the gist of what you were saying, like the redevelopment, the trying of a new framework. All of a sudden, the new framework is not compatible. The runtime it's destined for doesn't have the supporting packages as per the requirements.txt. So then you got to get with infrastructure, maybe deploy a new Docker image that's going to host it. All those types of checks and balances can be automated, which is nice. So you can try something, and before you can even, like for instance, you can even automate the process of notifying the team that takes care of your Docker installations or Kubernetes or whatever kind of container orchestration tool sets you guys are using, to notify them to say, hey, we've got a new build that requires this new requirement, and then to communicate with the developer, and then the developer might say, oh, no, we found a workaround, it's okay, we're going to revert to the old one. Like a million things can happen, right? Does that make sense? Is that on the level with what you're saying here?
Yeah, perfect. Excuse me, I was using the other microphone. I have like
there you are.
I have 3 computers right now. In one time, I have a laptop here, and the microphone goes from there, and then I'm looking right now at some automation of some scrapping and etc. Yes, but more or less like that. Do you believe this kind of ModelOp can help you to try to keep that balance where you need to deploy fast and then you need to keep everything more or less standard? And all the problems that comes around that when you change. For example, it happened to me. I spent 2 months moving a code from TensorFlow 1.0 to 2.0, and it was only one black box of the entire process.
Yeah, absolutely. So there's a few ways we do that. So, and this is, again, I'd like to speak about this conceptually from a model ops perspective. A model ops solution should be able to perform what is called an initialization function. If you're going to be doing some batch scoring, for instance, if you're going to be doing batch inferencing, you need to be able to ensure that. So if we look at the source code of this particular model, this is a very simple classification model. So this is binary output. It's called the German credit model. So it's just do you get the loan, yes or no? But the point is that there's an initialization function that needs to happen before a batch run that will then do all the types of things like a pip check requirements.txt. So if we look at our assets over here, there's your requirements.txt. It's part of that. It's the required libraries. All of that needs to be set up prior. One of the big challenges we have, and this all depends on how you choose to set it up, but like the space that we operate very frequently in is the banking space, and they're typically pretty locked down. So to allow a Docker image or through a, through the Kubernetes gateway out, and I say Kubernetes, but any orchestrator really, all the way out of the organization to reach out to any kind of like a PyPy repo and to grab whatever package it is that you want to grab and to bring it in for the dynamic run inside of that container at the time of execution, sometimes that's not always possible. So one way we solve for that is with tagging. So what you're looking at right here, these tags are actually just a way of associating to say, okay, well, this new model, like you were mentioning, TensorFlow, we were using this library as part of our code, our TensorFlow model, and we have an image that supports it, and that image is specific. And if we're going to be deploying a model with the newer framework added to it, or the new library added to it, then we want to deploy it to that specific engine. And that's kind of what this tagging, this metadata information about the model is all about. It allows you to associate where you actually want to deploy to a specific runtime, and that's what these tags are associated to right here. So you could say like TF1, TF2. Right. So maybe the TF2.
Can you basically keep a track of what you're deploying? Because I found something really weird in the last deployment of a Docker where I simply say, let me do a freeze and take this and move it to another machine, etc. to instantiate a new Docker. And you know what happened? It started to complain, this package doesn't work with this package. And I couldn't recall what was the way those packages were installed, and is that ModelOp be able to do that, to recall basically the sequence of possible installations? Because it's kind of funky when you start to realize how you are really dependent on the moment of development of the Docker, etc., and how do you install the stuff, and sometimes you cannot repeat it. And then you need to do some downgrade, upgrade, and etc. to make everything work.
That's kind of what that init function is meant to do. So if the init function finds an error when trying to deploy, and if the requirements or requirements.txt or the requirements themselves cannot be satisfied, it's going to cut you off. It's going to say, sorry, you can't deploy your batch run here because this no longer works. So there is a bare minimum of detection of error, but there's not a comprehensive cross-functionality check to make sure that like this framework only works with this other sub-library. I mean, that's more
That's
like
a conundrum. That's a big conundrum, basically.
Well, it is, but it's a good question. It's a dependency interoperability question. That's what it is. And there are, actually, I have a question for one of my own guys here. So John Carter is on the line with us, and he's one of our engineers that works on our software. John, are you there?
I was muted, but yes, I am.
Ah, there he is. All right, so John, I have a question for you.
Yes.
So Andres here was asking an interesting question about auto resolution of dependencies based on shifting frameworks or shifting use of libraries. And it's not really our focus. I mean, we're not really in the business of doing exactly that. But from a programmer's perspective, how do you handle that?
That's a very good question. So I can say from, so a lot of my work is generally done in Python. Now it's not data science work, it's more on the infrastructure side of things. But if, dependencies change or something along those lines, essentially just pinning everything. And then as the dependencies change, if something stops working, during test runs, you'll catch that immediately. And then updating that. So something to kind of tie it all back, a model operations platform, part of the model inventory are those requirements, are what it needs to run. So as the model gets updated, as you say, go from TensorFlow 1.0 to TensorFlow 2.0, you update that requirements file as well. And in theory, that would solve it. Now, nothing ever works in theory when you get to practice, but
but also one
That's
of the
true.
issues I think what Andres is also hitting on is like, say for instance, we deploy, and I know this is a bit off topic, right? Because this is not really the core of what we do, but I do like the discussion. I like the fact that this is a workshop and dynamic. You try to deploy to a runtime, to an engine, or to a container that you hope has the dependencies for you, but lo and behold, you do that and it doesn't work because the container or the runtime where you're trying to deploy to is unable to reach out to the internet at large and actually pull new packages in to solve the dependency problem. We have the mechanisms in place, and our init function is intended to do that for customers. And actually, this is maybe also a question for John Carter, because I used to be a Linux sysadmin. I used to work with tools like Satellite, which are meant for internally distributing packages and code packages and libraries to things like Red Hat servers, and that's one thing. And I'm just using that to draw a simile, but John, are you aware of like a localized, like an enterprise PyPy sort of deployment? Is that a thing that could be utilized for containers that are in like a banking or in a finance type organization?
Oh, so we actually run one internally at ModelOp.
Oh, there you go.
And yeah, so it's and kind of the beauty of the way that things can be deployed, especially if you're using something like Docker, is you can set it up to pull from wherever you want. Python gives you the ability to change the servers and that kind of thing that you're actually pointing at. So you could point at something internal, you could point at something external, and then you can also kind of bubble up what the actual issue is. So for example, if you were to deploy to a runtime and you wanted to use external PyPy and it couldn't work for whatever reason, it couldn't connect to the internet, who knows, you could, using automation inside ModelOps tools, you could then detect that, wasn't able to deploy because of this issue. Let's now deploy it to a runtime that points at our internal PyPy that we know we can connect to. It might not have the latest version of whatever it is, but it's good enough it'll work, something along those lines. So you can, tying with the automation, you can automatically, if it doesn't get past the init function, you can tear it down and deploy it somewhere else to where it will work.
Yeah. So, Andres, I hope that we've given you a few tidbits to chew on here. I don't know if we can answer the question fully because it's a tough question to answer. But,
no problem. Thank you very much. I'm coming from the mathematical data science kind of. I'm a programmer by master and PhD, but I'm actually a mathematician, and I've been kind of getting into how to deploy this stuff, how to automatize the stuff, trying to broaden my perspective, and I'm starting to be quite respectful of the people who maintain these users there in the web. I really, it's an art, and I can say that I respect that a lot.
It's tough. It takes a lot of consideration, a lot of forethought and that's why CI/CDing. What you're hitting on is the again the raison d'être of a solution like ModelOp Center, like what we've built out here, is because our customers came to us with that exact same challenge. How do you account for all of the different requirements and the business process and all the checks and balances necessary to allow a model to make its way into production? You need to be able to have a mechanism and a tool set, just like developers use CI/CD pipelines. You need an equivalent tool set for models, but it needs to be from a different vantage point. It needs to be business focused. It needs to be overarching, and it needs to have all the components like we were talking about over here. Okay, so we have two other questions here. What I'd like to do, so there's one from Adarsh here. Possible, recommended to have an expedited pipeline for fast tracking the process in conditions of time constraints in the point of view of both regulated and unregulated projects. Okay, I can answer that question in a sense with an example. So if and this depends on what is exactly meant here, and Adarsh, if you'd like to pipe up and to share your thoughts, by all means. But what I'm getting from this is that, and consider one of the deployments that, or the types of deployments that we have. So here, let me show you this right here. Okay. So throughout the automations that you're able to build out, and that you should be able to build out with this type of solution, you need to be able to perform weighting, or you need to be able to enforce time constraints in your automations and allow them to basically run indefinitely unless a specific condition is met. So your question, is it possible, recommended to have an expedited pipeline for fast tracking the process in conditions of time constraints in the point of view of both regulated and unregulated projects? Conditions of time constraints. So I guess the answer to your question is a combination of something like you're looking at right here, with the variety of automations that can be built out, because you can redirect the request of having an unregulated versus a regulated model go in one direction or the other based on the metadata tags that I was just talking about earlier. So you have the ability to redirect into a more time-sensitive automation or a less time-sensitive automation based on what is important there, and that is for you to lay out and to craft out in the way that you would like to see it happen. I don't know if I'm answering your question though. And again, if you'd like to add more clarifying comments, please feel free, or if you'd like to hop on the audio, we can talk it through. And I see a question here from Nick Tran. AWS SageMaker, there's a link here with a YouTube overview. That link isn't available. Oh, okay, so I see Zach. So Zach Trent works with me over here at ModelOp. He's providing the link. That's great. Okay. Oh, the YouTube video. Nick, we can help you out. We'll find you the link necessary for the YouTube from that page for sure. And if it doesn't work, maybe we can pull a different version and provide you with a link directly, if that's okay. So before I answer more questions, because I do love all this, this is great. This is a good discussion. I want to proceed with a bit of a story here about how you can leverage some of the automations that occur as part of ModelOp Center, but more specifically of what you should expect of a ModelOps platform. So we're gonna have a look at this automation we were just looking at here before. So this is the productionalization tier 1 deployment, and we just call it that because you might have different variations of types of models that are put out there, different risk classifications, things of that nature. And we're going to automate the productionalization of a model. And we're going to include documentation, and it's going to go through its back testing, and it's going to do a Veracode scan. Although we're not using, this is just a demonstration environment. There's no Veracode, but I can show you what the result of a Veracode job run by a pipelining tool such as Jenkins would look like inside of our software, because we're able to go and again, ModelOps has as a purpose to centralize all of the logging, the auditability, all the traces of everything that is done with your models, including the metadata, the historicals, all that good stuff into one place, because the business needs to know where all of the decisioning assets that they have created over time are currently residing, where all the information is about all of them, and all that good stuff that goes with models. So on the right, this is just a simple little page that one of our engineers whipped up that's just meant to register a model, a blank model. And what that looks like is this. So if I return to my model page over here, I've just filled this out. So the organization's gonna be us, it's gonna be the TMLS model, okay? So model for the TMLS event. We can, just as part of this page, we have different classifications for, or actually categorizations for the types of model this might be. It doesn't really matter what it is, just for the purposes of explaining what we're gonna be doing here, but I'm gonna choose, they say, a decision support model, sure. And then I'm going to go ahead and I'm going to upload a use case document, because I am from the business. I want to register the need for a new model, and I want the model development team and also the validators to be made aware of the fact that this is going to be coming through the pipeline. So I'm going to double click on this, and I'm going to choose my model group being ModelOp, and I'm going to create the model submission. And if I return on my left over here, an inventory item will have been created called the TMLS model. So that's great. So I'm going to go in here, and right now it's just a use case. Nothing else is really going on here. If I look at it, it's pretty well blank. There's not a lot going on. But what happened in the background, and let me go over here, if you'll notice, and you guys didn't see it go live, but right now we have one process that's sitting here and waiting. So we're waiting for the risk assessment completion of this model. And how is it happening in this particular sense? A little bit, like I was mentioning earlier, about I guess an hour ago, we were talking about how organizations have varied mixes of tool sets of enterprise software that they need to work with. You can't always go and speak to the validation team, to the risk team, and say, hey, well, why don't you just have a better ticketing system? The enterprise edict is to use this ticketing system. In this case, just for demonstration purposes, we're going to use Jira. So Jira is just an ITSM system that you can use to create tickets, to assign tasks, things of that nature. I'm sure a lot of people that are on the line with us today have seen this or used it themselves personally. And what we'll notice is that right here, and this should have been created 1 minute ago. So this is us. We just did that. That was our automation created that. And this ticket has the use case for us. It says, please review this notification, which is this actual ticket. A new model has been registered. Please review the use case document and assign a risk level. So I'm a model classifier, or I'm a model validator, and I'm looking at what is involved in this actual model. I want to open up this use case document. What I can do is I can actually show you, instead of going through the whole rigmarole of downloading it and looking at it. If I just go into here and then here and then here, and actually just look at the actual document, it looks like this. It's nothing really to. It's kind of ugly. Make that a bit bigger. There we go. It's not really much to phone home about. It's just a model design document, and this is just a template that outlines all the different types of things necessary to document as part of a model. And as you can tell, and if you haven't seen this kind of thing before, it is extensive. And if you have seen this kind of thing before, a lot of this is probably very familiar to you. So you have a number of different facets that need to be filled with an executive summary, what needs to be put together, what is the intent of the build, what is actually being put together, what is required really of the business. So that's that use case document, and that is what is attached here to this ticket. So please review it, make sure it looks okay. I review it, I say, I'm gonna hit edit here, and I'm gonna say, well, this is a high level model risk here. And I'm gonna hit update, and I'm gonna focus on this automation right here. So this is gonna continue along. And I'm going to go and say, okay, I'm done with this now. So done. The green boxes light up. We've made our way over here. Wait for the model development completion. So I guess I don't know if I'm interpreting this correctly, but Adarsh's question from just earlier, time sensitive or slower or faster deployments. The thing is that the automation engine is meant to have instances of the automation persist through time. You can't just throw them out and say, no, we're done with you. You need to be able to have those automations stick around for a long time, because the development of a model could take months. I don't know, it could take years. It depends on how long it's supposed to take, but you're waiting now for model development completion. How do you then complete the development of a model? Well, we go to the model itself, we're gonna hit refresh. One thing you're gonna notice is that the metadata now includes a model risk of high, which we set in that ticket. So we read that information back in, we added it to the metadata here, which is great. We're now gonna add a Git repo. Let me go ahead and get my copy paste that I can put in here. Sorry, guys. I wanna make this fast so you don't have to sit around, and we're going to use that German credit model that we were looking at before. So we're going to point to a Git repo on GitHub, and we're going to grab the MRM, which is Model Risk Management branch of this specific model here. I'm going to hit add. The code was just added over here, and now you have still wait for model for model development completion, and that's fine. So now that we have this Git repo synced here, if we look at our sources, all of a sudden it's populated with code. If we look at our assets, all of a sudden we have assets that are now present and part of the actual model itself. This is great. So what it did is it reached out to that GitHub. If I go to this site right here, this is all the information that was just pulled into this model. So the model development process was completed. You have now imported the code and all the assets that are associated to the model as part of that inventory item. Again, another crucial aspect of model ops as a concept. You need that. You need the automation, the inventory. And now in the inventory, as part of this right here, I'm satisfied. I've got my code loaded here. I can go ahead and I can go and check to see if there's something that is waiting for deployment. If I go to my model operations ticket queue here, so your model has been reviewed and the risk assigned, please begin implementation of the model and attach source code to proceed. The attachment of the source code was just done by us. I'm seeing a little message here from Adarsh here. So consider for this case, if we are not required to verify README file, just an example, can we bypass this stage as an exception? Yes, absolutely. Okay, so Adarsh, you're hitting on a very good point here. So one thing that is possible with the validations that we're doing on the right, so you're looking at the automation, and this is just for the purposes of demonstration again, is outlining what you would typically see in the handoff between a model developer and then the validation team. But what you are also able to do is to parameterize any of that. So you can add tags, you can add metadata, you can customize what needs to be validated for a specific type of model. If a model has a different risk classification, that could send it down a different route in the exact same automation. In our particular case, it's relatively linear. It's linear with error catching. However, you can craft it out to go in the direction that you'd like it to go. I hope that answers. Yes, and exactly. So to Zach's point, he just answered there as well. It is completely configurable. You can send in enumerations and arrays of things that need to actually be checked on as part of the automation. And that is a how you build it type of question. And again, hitting on the fact that automation is one of the three foundational pillars to make up governance, which is what ModelOps, the notion of what ModelOps brings to the table, really. So on the left, I have included my source code. I'm happy with it. And I can now go ahead and say that model development is done. So I have proposed a model, the code is in there, but now the code needs to go through all of the scrutiny that you would expect as part of the validation process in an automated fashion. So I'm gonna hit done. You're gonna notice on the right, it's gonna continue through the process. Right now it's running some standardized tests, which is just a little batch run. I can zoom out a little bit here. So it's still just running right there. While it's running, it's doing a few key things just to make sure the stuff is in line. And then we are now waiting for document completion. So what that means is So we've done a few other validations. We made sure that the assets are in place, meaning everything that was loaded in as part of the model. And this, again, is a model validator's job, is to make sure that all of this stuff is there. But do I really want to be reading lists of things from a day in, day out perspective? No, I don't. I want to have a system tell me these models keep failing their asset test. These models have made their way most of the way through and just need a few other points checked off. These models have made their way through today. These models were completely rejected because of some specific issues, maybe related to performance or to agreed upon performance for the actual back testing and for promotion to production. So we're now waiting for document completion. And what that means is if I go over here, I'm going to hit refresh. So notification from ModelOp, documentation of the model TMLS model must be completed in order for the model to continue processing in the ModelOp system. Okay, so we have this review documentation. And if I was going to be reviewing this, I would want to download it and make use of it, and then figure out what needs to actually be filled. And what that looks like is this, actually. So I'm not going to go ahead and download it for you. There's not really much for a reason. You can bring it out of Jira and then re-upload it and do all that kind of stuff, which is really what this serves as a purpose. But if I open it up, this is what it looks like. So this is the actual exec summary. What is the model supposed to be spitting out? Its actual stability, the gender, the credit history, the things that it should be beholden to. What you're going to notice are these tags, everything you're seeing here. So this is an example of automatic documentation creation. Okay, so this is an important aspect to what we're putting together. You can templatize, so models that are grouped in a specific way. If you know that your classification models for, say, credit lending are classified in a very specific way, then all of those types of models might have very similar documentation and might follow the same paradigm. And because they follow the same paradigm, they probably have to have the same results of analysis be part of the documentation before they're even allowed to proceed. But this is just to ask you, hey, does this look all right? Is this the right type of model review, of a model review document that you should have as part of this flow? Yes or no? Load in the right template for what it is that you need so that you're actually saving it then as part of the actual model itself. So what I'll do here is I'll go ahead and I'll set this guy to done, and we'll let that continue. So the document is completed. We're grabbing a snapshot. And right now we are running tests and analyzing results. On the side, it very quickly did a Veracode scan. I mean, that's not much to really look at, but I can show you what that looks like after the fact. We just ran some tests and we want to analyze the results. So we want to make sure the developers, and this is again in the subject of de-risking your models, you automate all of the things that all the checks and balances that can be automated within an environment to alleviate the effort required by the model development and validation team to make sure that you are getting your models into production, even though you have a horribly complex and tedious process at hand that needs to be done every day, day in, day out. And it's hard. It's very hard to find data scientists. It's hard to find validators. We're living in an economy right now where finding good talent to be able to do both of those things, and like I was hitting on earlier, validators and developers have a massively overlapping skill set. You need to be able to find people that are willing and able and have the knowledge and the mathematical knowledge to crack open the hood and to say, okay, this data scientist is proposing this math to solve this specific business problem. Is it appropriate? Are the coefficients correct? Is the choice of framework or library correct? Or the choice of math to solve the problem correct? Was all this done correctly? There is so much at play that if you can automate as much of that as possible, you can alleviate the burden. And again, that's the purpose of ModelOps, and that's what it brings to the table. So what just happened, we ran a back test and we performed a quick Veracode scan. And what does that look like? So over here in our jobs, so this TMLS model just ran a little metrics test. If we look at the details, you can see the output. So this is it deploying to a container, doing its thing, reading in the input, the baseline data, sample data, performing its inferences, and then spitting out a result And then what you can do is, if you see this is just the log result of that, and that's great. You need that for posterity because you need to make sure it was done if you were to look back in time. But if I go to my TMLS model here, and I look at this snapshot that was taken at this specific time, which is right now, and I open it up, I hit details here. A snapshot is a version of a model. You need to be able to control for this, because after you create a version of a model, it should be immutable. And immutable means that you just can't change it. Like if I were to go to the actual assets and documents here, I can't change these anymore. I can't upload new ones or delete these. These are all stuck in time, and they're kept here for posterity. Very important as part of any kind of model ops solution that you want to put into place. So what did we just do? We ran a metrics job. What does that look like? Here's your accuracy. Here's your performance. We also did some standard risk tests over here. So if we click on that, we've got a quick stability analysis. Not much to look at. It looks like it's pretty stable. Everything's just right across the board, along with some other, let's see here. This is the stability analysis table. This is why it basically is like the mean differential is just 0. So that's why it's kind of flat. You've got your performance as well. And then a little bias check. That was part of the actual data itself. So you have information about how it actually performed and whether or not this matches specification. So a validator will then open up a document and say, okay, this looks right. It looks like it conforms here. Performance, our confusion matrix looks good. Everything looks fine there, and stability for the data, the population of the data looks good as well. I'm happy with that. Again, we have another performance test that was done, a quick smoke test just to see how it would run, and again, it performed well. That's great. What has happened now? Oh, and sorry, one last thing. We also wanted to, and I can show you what that looks like over here. If I return to my jobs and I scooch forward a few, here's a Jenkins job. There you go. So this is a Jenkins job that performed a scan, a Veracode scan. We don't have we're not paying for Veracode licenses, are actually quite pricey just for demonstration purposes. But what you see here is Jenkins being invoked to perform a pipeline run, to perform a Veracode scan, to check the libraries and the frameworks to make sure there's no vulnerabilities like what I had mentioned earlier. Come back in and again, add that as part of the posterity, add that as part of the logging and the audit trail necessary for your actual model. So again, very important. So that's good. And what I'll do right now is, on the right over here, we are at wait for review. What do we have to do here? So we need to go see where we've gotten with our model as a whole. So we return to our ticket queue over here. I'll hit refresh. We've got demo 463 that was created. So a review of the model TMLS model has been requested in the ModelOp system. What I just did, so here's your model review document. If I open this up right here, what's happened is the test results that we were just talking about. We had the template before, but now it has been dynamically filled by our software. But the point is that it's been dynamically filled with the test results that we were just looking at before. So for instance, the stability analysis, like we're looking at gender, age, and just a few other key components of everything we were looking at. Although these guys are flat, I think this is just a render thing that's going on with our, oh, actually, sorry. No, okay, no, it's because we're testing for something different, but it doesn't matter. Point is that you're adding and you're creating automated documentation based on the results, and a model validator would look at this, open it up and say, does this all look all right? I think it does. And this is the type of review and documentation that you might want to see. So I'll close that, and this as well. I don't think we need this right here. And I'll say to myself, okay, as a validator, this looks fine. I like what I see. Everything seems to be in order. It's performing correctly. I've read the specification. It's doing the things it's supposed to be doing. I'm going to go ahead and hit done here. And what'll happen now is it'll allow the model to be deployed to an engine. And what that means is that in this particular case, we're going to be serving this on one of the ModelOp runtimes, if I'm not mistaken. And here it is right here. So the TMLS model was deployed to an engine that was tagged as MRM. So the model risk management team has a place where it can deploy these, and it was deployed to a Challenger engine. So what that means in this particular case is that this is a proposed candidate for production. Doesn't mean it's the ultimate. Doesn't mean it's the ultimate end state. It might be. and here it is, and you've got your endpoints exposed maybe for doing online inferencing. And you could also run batch jobs on the snapshot itself anywhere else you'd like to run them, and that's important. That's an important aspect of a ModelOps solution, because you need to be able to then pull that information back to a central location and analyze it. So just some really good information to have. And now we have another review where it's saying that another review is required. It's sitting on an engine, maybe where it is right now, and as you see in this automation here, deploy to validation environment. It can sit here and wait for review as long as you want. So you can have this engine running this model, and it could be external to ModelOp Center. It could be internal to ModelOp Center. It's as you see fit. You have this Challenger model sitting right here, and then you also have this prod model with the TMLS loaded as well. So they're both there, Champion, Challenger. You can have these run as long as you'd like them to be there, which is great. So the point is that you have that dynamic ability to do that type of thing. I know we're coming up to time. We have about 19 minutes. I want to hit on one other thing. The purpose of this was to illustrate the fact that you can automate the validation process between development, so first and second line, so that your models that make their way through and from concept all the way to retirement, you are following and automating as much of that as possible in a model-centric context. That is the goal of ModelOps. That is the way you de-risk. So you force people to adhere to a process. You don't allow them to detract from the process. This is a set in stone process that is configured once. You separate, like segregation of duties, right? So you have two teams, like there's a firewall between first line and second line. The folks that are developing this kind of thing might sit on the governance team. You don't know where they sit. They can be in a variety of different teams, but the point is that they all come together to be able to craft this type of compliance automation, so that the organization minimizes its risk by maximizing throughput of what is checked automatically, which gates it forces the developers to go through, and even just like we were talking about E23 before, like all the things you have in E23, you can literally the automation we have here on the right, as per one of our VPs, he worked for 17 years in data analytics. He worked within SR 11-7 guidelines for a very long time. What you're looking at here in terms of an automation is pretty closely mimics what you would expect of SR 11-7, and that's how you de-risk yourself in light of especially government bodies like the SEC, ORB, south of the border, to be able to look into your models and to make sure that you're actually running them in a correct fashion. It's very important. You need to be able to do this type of thing to also not drive your validators and developers crazy. This is a great way for them to work together. This is a common ground for them to share, to be able to just be better at their jobs together. Sorry guys, my dog is losing her mind, I think, right now. I think there's someone at the door. So that was just a quick story about that, but there's one part of this I haven't really touched on, which is monitoring. And how do we do that? So you want to be able to centralize in a ModelOps solution the results of the monitoring so they can be tracked over time. But I think it's this guy right here. I think my colleague put this up here. Yeah, he did. This is great. So, sorry, let me pause that. So what this is right here is the results of a stability analysis on a specific model that we have. And the reason why it's important is because you can, if you so choose, generate what are called breach reports based on the thresholds that you set for your monitors. So no matter what kind of monitor you have, a ModelOps solution needs to be able to accept the input and output data, or the sample data, or the baseline data, or the training data of any of the types of models that you bring to the table, and needs to be able to analyze that with all the standard algorithms that we see out there. So I'm just gonna go back to the core here and go back to the models and go switch to monitors. So you're gonna notice a lot of the usual suspects here, okay? Things like data drift, concept drift. We also have something called the business value monitor, but bias monitoring, of course, performance monitoring, stability, standard risk, volumetrics. All of this right here very much the basis of most of the monitoring that you're going to encounter out there in the wild. So performance is pretty easy to grasp, but things like data drift and concept drift could be model dependent in how it is that you're applying it to them in terms of other population of data versus new population. How are they different? Doing your KS scores or you know, your distances between how your data was and how it is now. You need to have all these options, but in a sense that allows you to bring any model to the table and be able to analyze them and gather information for posterity. So this is a very important concept specifically for model ops, because you need to be able to make sure that everything is running okay across the board. Now, back at my models, I think I was looking at this guy right here, the Canadian Consumer Credit Default Prediction. Now, that we were performing a stability monitor on this particular model. And what I'll do is I'll edit this monitor. I'm going to do something. I'm going to grab this right here, and this is our stability, what's called a DMN file. So it doesn't. This is not the only way to do it. This is the way we do it, but it's just to show you an example of this. A DMN file it's under the hood. It's basically just XML, and it's decision modeling notation. So DMN is a way of creating thresholding. That's what we do to allow you to say, hey, am I bursting past the threshold? Am I within my confines? Am I operating correctly? What I'm going to do here is I'm going to put this back to the way it actually should be. I'm going to hit save. Next step. I'm going to set save. I'm going to return to my demo Jira here. Let me hit refresh. This is done. That's fine. I'll let this guy go through. Okay, great. And I want to do open issues. Okay, good. There's no open issues right now. Hit refresh. Beauty. I return over here. I have put the threshold back to the way it was before. I'm going to hit play on my monitor. By running a monitor job, you are running a batch job. So you're interpreting a large amount of data to see how far you have drifted from whatever it is you're looking to analyze. In this particular case, it's a stability analysis. We want to see about the populations of used data as part of the model itself. So it ran through a quick stability analysis, which is part of what we call a metrics function. So this is very specific to kind of the way that we operate, although similarities will exist pretty well everywhere else. And this is something you should expect from a model operations tool. I'm going to return over here. We're going to go to models. I'm going to go to my consumer credit default prediction and grab the snapshot we were just looking at. And there's a new, so I just created this right here. So this is our stability monitor. I'm going to click on it, and things look okay. If I return to over here, so the TMLS model failure to deploy model. Oh no, sorry, this is this is from another one. Let me hit that on that guy. I do open, refresh. Give me just my open issues. Perfect. Okay, that was from something different, and we're going to leave that alone. Probably my colleague is probably doing some testing. Over here in the stability analysis, we have our analysis that was done with that threshold of 0.25, and that's fine. But what we're going to do now is we're going to return to that monitor, and we're going to do an edit on it. And nothing happened here. We ran the monitor, it saved the data point, and it created the report on that, which was just this right here. So we have that point in time of information. If we hit monitoring over here, there's no flat metrics to actually to show just this moment. And that's okay. We have our results as they should be. So this is fine. We're going to leave this here. Nothing was breached here. But if we return over here and we hit edit and we return to that DMN file and we mess around with this. So I put it back to the way it was before. And I hit save, and I hit next step. I don't need that, and I hit save here. I'm going to run another monitor. So the monitor job started. It's going to redirect me. It's going to bring me there. This will kick off. It'll do its thing. And what's going to happen is that it's going to generate. So let's see here. So the batch job is complete. That's great. I'm going to return to my actual model itself. So models, some Canada Consumer Credit. I'm going to click on the guy I have right here. You're going to notice this right here. So we have an issue with the model that was just launched. This is the stability analysis that was just conducted. So we have our information about that and where it's sitting and the thresholds that we set. More importantly, what happened is a ticket was created. Oh, Oh, geez, look at that. Okay, so we've burst past the specific threshold. We just automated, and what happened in the back end is that the monitor will have kicked off an automation. So it's a very short automation. You don't really see it pop up too quickly, although we could probably find it. It is probably monitoring job. Is it this guy? Yes, here. So we have this guy sitting here and just waiting for notification, and this is a standard monitoring job. So this was kicked off. We performed the model run, right? Did the test pass? Yes or no? No, it failed. Okay, grab this, store the notification, review the notification, and then complete. So that's over here on the left. So we've interacted in that way. We've created this breach report. And if I open this up, what does it look like? I'm gonna say yes here, that's fine. And this is not much to look at, guys, but it's just enough to explain that, you know, you've got some stability that's indicated like this. You have some information regarding this. This is now stored for posterity. This was created at one point. And for ongoing operations, what has happened is we now have a breach. So something bad happened. We need to log that information, store it somewhere, and we need to be able to adapt to whatever kind of mix of environment people have. So something very desirable when you are operationalizing your models and making sure that they stay compliant from a day-to-day basis. So I'm going to go ahead and just hit done over here. This guy should complete, and there you go. So he's done. And that's it for that. That's it for what's called a breach report based on an actual monitor. So another different case there. So we have a few minutes left. We have 8 minutes left. I'm open to chat about whatever it is that you guys would like to talk about for those who feel like sticking around. I hope this was informative. I hope that this served the purpose of showing you what you can get out of a bit of software like this, what some of our own customers get out of this, and what's important to internalize is that you can innovate as you want. You can build your business process into this software to match how you want to govern your models. You can reduce your deployment time, and you can integrate with your own unique infrastructure. These are just kind of the key bullet points that we like to bring to the table when it comes to choosing a ModelOps solution that very specifically is made to do this kind of thing, which is to take care of your models and make sure that you adhere to your own business process. So with all that said, if you guys have any questions, I see that's Janet. Okay. Yeah, absolutely. So Janet posted our email there. If you guys have any questions, if there are any aspects of this that you'd like to discuss, that'd be great. I still have that other question from earlier. I will relay that to one of our data scientists, and we can have them kind of, obviously, if we can, with your contact information, we can reach back out and provide you more context. Copy of the slides and the recording. So the slides, maybe. The recording will be through TMLS, I believe, so that's a yes. The slides I'll have to ask on the back end because there's some I guess some proprietary information there that I don't know if we can share. We might be able to, maybe in the form of a PDF, but let me clear that first if that's okay. No problem. All right. Just as a point of interest, has anybody here actually read through this, the actual OSFI guidelines? So if you're having trouble sleeping, it's really good. So I mean, you can do melatonin, but this right here, this is pretty well the best. So if you start reading this, I'd say by make halfway in page 2, you'll be out cold. It's brilliant as a sleep aid. And I guess, guys, with that, I figure if you guys don't have any questions, if you're not posting anything here in the chat, I hope this was informative. I hope this got you guys thinking about a new type of. Oh, is someone asking a question? All right, I see Guri's there.
So yes, wonderful. Thank you, Jonathan, John, and Janet, for your time and the very interactive and interesting workshop. You walked us through the ModelOp Center solution. And thank you, attendees, for your time and interest. I'm sure everyone learned a lot, and we have a lot to connect back with ModelOp after. Enjoy the rest of the event, and the recording will be shared with you through TMLS.
All right. Thanks very much for joining, guys. Take care.
Thank you, everyone.
Bye-bye.